Okay, hello everyone. Good afternoon. Welcome to OpenFOAM 19th conference. I'm Qin Chen from HPC and AI Advisory Council. So today I want to talk with you how to leverage the networking technology to optimize OpenFOAM performance. Our previous speaker, Patrick, he introduced how to leverage storage to do some optimization for OpenFOAM. Actually, the storage also can leverage networking. As Patrick mentioned, for OpenFOAM, usually we may run the application on top of millions of processes. When we do the millions of process distributed computing, the networking is playing a very important role. So before we talk about OpenFOAM, I want to just explain what's our community. So our HPC Advisory Council is like a non-profit organization. We have more than 450 members. So we're mainly focused on different HPC and application in large scale, how to optimize HPC and AI application, how to bridge the gap between the industry and university to help the university and research center to get the latest information from industry. So this is our members, including the industry leading company, the major universities in worldwide and research centers. So in our HPC Advisory Council, we're not only doing some researching, we also provide the state-of-art HPC cluster and AI cluster for our members. They can apply the free access for our system to run their application in our data center, in our lab. So every year from HPC AI application, we publish the best practice which we were running in our lab. So which cover the major HPC applications. Here is a list. I will not talk about detail, but every year we will update the list. We run many applications, then we publish those best practice in our website. So if anyone you have interest in to learn the latest HPC application, how to get the best performance, you can visit our website. Also, every year we are running some students competition. So for those student competition, we offer the like HPC and AI technology training for the university students and the research centers researchers. Then we find some very interesting tasks to give for those students to do the competition every year. So we have the competition in worldwide. Also, we have a specific competition in APAC region. Also, every year we're running some technical workshop. So we run this kind of workshop in every year to do the exchange, knowledge exchange for our members. So now let's talk about what's what's a nice data center, HPC center, or what's the best HPC center which we should build to run HPC application. So for the traditional HPC application, so when we build a large system, the communication is always very critical. If we don't have the right technology, we will see this kind of scenario. Okay. So you can see this is latency-free HPC application framework latency. This is a ping latency. You can see the latency is very high. Also for the communication and computing, what's the percentage of communication and computing? You can see the communication always consume a lot of our time because this is because of wrong communication. So how to resolve this problem? There is a new technology. Actually, this is not new, but it's a very nice technology. Technology we call RDMA technology, Remote Direct Memory Access Technology. So like in previous Patrick's presentation, he was talking about use Lustre to optimize performance. Actually, Lustre is also based on RDMA technology. Like 20 years ago, when my first time to use Lustre, the Lustre performance was not so good. So then after they moved from the traditional communication to RDMA protocol, then I remember at that time, there's 5 to 7 times performance improvement. That's a very nice performance improvement after move from traditional communication to the RDMA, to the remote direct memory communication, memory access communication. So with RDMA, you can see this is the red color is the communication time. The communication time reduced a lot. Almost we use all of the time for our computing. Also, you can see the ping latency also reduced a lot. It's become much, much lower than before. But still, the HPC framework latency for some kind of communication pattern still very high. Because when we do, for some HPC application, when we do like some collective communication, the collective communication may create some congestion in the network. Those kind of congestion will impact the application latency a lot. So how to resolve this problem? Then we move to the next step. Before we talk about next step, we also, when we talk about the RDMA technology, we are not talking about only between CPU memory to CPU memory, you can do the direct memory access. You can also do the direct memory access between GPU memory to GPU memory. So why we talk about this from GPU memory to GPU memory, there's two directions is driving this. First one is when we expect very high computing performance, we are changing from CPU computing to GPU computing. So when we use GPU computing, then you need to do the GPU RDMA, we call GDR, GPU direct memory, GPU memory to GPU memory direct access. So you can still use the traditional simulation run on top of GPU, but you can get much high performance. Another direction is AI for science. I think everyone knows AI for science is a very hot topic now. So more and more traditional simulation model now they are thinking how to leverage the AI capability to run the HPC simulation. This is not only run the HPC simulation in GPU. This is still traditional HPC simulation. What we are talking about is using our like large language model or multimodal model, use the AI model, or use our traditional CV model, use the AI model to do the simulation for the traditional HPC applications. Then you can get very lot of benefit. Like if you have the nice AI model, you may reduce like HPC simulation from like many days to few seconds. Because when you do the AI inference, you don't expect you wait for 5 minutes to get a result. Your expectation is like few minutes you want to get the result. So when you have the right AI for science model, you can reduce like the response from maybe a few hours to minutes, or few hours to seconds, or few days to seconds. This is a target. Also with the AI model, you can get more and more accurate for your simulation result. So because AI model, you can learn by the model themselves. So when you have more data feed to the AI model, then you will get a better result, more accurate result. So this is why GPU use RDMA is become more critical for HPC application. So now we are not only talking about this use RDMA, we also talk about the in-network computing. Why the in-network computing is important. With the in-network computing, we put the computing unit not only in CPU, not only in GPU. We put the computing unit also in the network, in the NIC card, in the switch, network switch. So for some of communication, if we put the computing unit from the host to the switch, then this can help to resolve a lot of issues which we didn't think even before, like the all-reduced communication. So when we put the all-reduced computing engine from the host to the switch, then the switch can do the all reduce Then when all of the host send data to the switch just to the all reduce. After the all reduce, just send the result back to each host. So in this case, we don't need any congestion control. There is no congestion. If we don't do the all reduce in the switch, then this all reduce communication may create the congestion. Like if we want to use this one to do all reduce, then when these two hosts send data to this one, this will create the 2-to-1 communication. This 2-to-1 communication will create network congestion. But now we use in network computing technology, there's no this kind of congestion anymore. So because we finished data aggregation, data reduction in the switch, then switch directly send the data back to the host. That's why in this case in network computing, you can see the application framework latency also reduced to very, very low. Okay, why we talk about this technology? Because OpenFOAM, they are using a lot of all reduce. I will show you what's the OpenFOAM communication profiling result in my presentation. So this is for the NPI, specifically for the NPI all reduce latency. We run the testing in 1,500 nodes. Each node we run 40 processes. Total is 60K NPI ranks. So with this kind of in-network computing technology, you can see we can reduce NPI or reduce latency about 5 to 6 times. Okay, so what's for OpenFOAM for this kind of application? So the all reduce is a major data aggregation communication pattern. So if this is an example, if we have 8 processes, we want to use this 8 process to do the data aggregation. Usually we can do this, we can do ring, or we can do this kind of aggregation. Like first we do the aggregation between 1 to 2, then also in the parallel, meantime we do aggregation between 3 and 4 and 5 and 6, 7, 8. After this, then we do the second type aggregation. Then this time we do the aggregation like between 1 and 4 and 2 and 3. This side, this half we do 5 and 8, 6 and 7. After this, then 1, 2, 3, 4, they have the aggregation result. For those 4 nodes, 5, 6, 7, 8, they have the aggregation result for these 4 nodes. Then last, we do the final time data aggregation, like we do the aggregation for 1 and 8, like 2 and 5. After this aggregation, then every node gets the final aggregation result. So this is a traditional data aggregation. When we use in network computing, that's very easy. We send the data send the data to this switch. This switch will do the aggregation. Same as these 2 nodes, also this to these 2. After those 4 switch do the aggregation, then the switch will send data to the up layer switch. Those up layer switch, they will do the aggregation for this data from these 2 switch and these 2 switch. Then this top switch will do the final aggregation for all of data. And then after this switch has data, then this switch will do the broadcast, send data back to all of the nodes. So this is in network computing. With this, there's no like many-to-one communication, because after the data sent from these 2 nodes to this switch already this switch can do the aggregation. Then this switch only send aggregation result to the up layer switch. No need to send the data from 1 to all of the data to the up layer switch. So with this, we can use a computing idea to resolve the communication bottleneck. Okay, this is a comparison. So with this in network computing, we can get very low latency. Also, almost no CPU utilization. Okay, so after we talk about this kind of basic concept, let's come back to OpenFOAM. I think within these few days, you guys already know what's OpenFOAM. So let's see, this is our testing platform. Our testing platform is based on NVIDIA Grace CPU. This is an ARM-based CPU. So we already published many OpenFOAM results in our website based on like Intel CPU, AMD CPU. So this is our new data. This is based on the ARM processor. ARM processor plus NDR InfiniBand network. Also, the NVIDIA quantum NDR switch. This quantum switch can support in-network computing, which I just mentioned, can do the data aggregation in the switch. So this is a software configuration. We use OpenMPI. Also use this is our OpenFOAM version. So we did the testing for the this is testing for the pimp form. So this y-axis, this is 10 steps per minute per node. So this is node number. So we tested the 8 nodes. Each node we have 144 cores. So you can see the speed up is very close to the linear speed up. So this we just did this. We just working on the initial optimization. We will continue to do the optimization with the in-network computing for the OpenFOAM. This is based on the C form. This you can see. This is even better for the speed up. So this is speed up based on the pimp form, X form, and 3D cylinder. So you can see each model you can get very nice scalability, almost this line speed scale out. Okay, this is a very important slide. Why we talk so many or reduce? This is we do the profile for pimp OpenFOAM. From the profile result, you can see more than 60% of the application communication is based on the or reduce. So if we can do the or reduce optimization, it's obvious we can optimize the application performance. That's why we can leverage the in-network computing technology to reduce or reduce communication time, then improve the application performance. So here we can do a short summary. So OpenFOAM, we can reach the great performance in ARM platform. So not only in x86, also in ARM platform, you can get very nice performance. With NDR InfiniBand, we can get very close linear speed up. We are still working on optimization to reach the real linear scalability. But now we already got very nice scalability. Also from the profile result, we know or reduce is a major communication. So when we want to optimize OpenFOAM application performance in the cluster, we should think about how to optimize or reduce performance. This will bring us big value for the OpenFOAM application performance. Okay, finally, if anyone is interested in HPC AI Advisory Council, you can reach us through the emails, through the LinkedIn, Twitter. Okay, thank you.